right, good morning, everybody who's joining us. My name's Gator, and welcome to another webinar sponsored by the EnviroHouse. Today's topic is heat pump systems, heating and cooling, and water heaters today. So a lot of good stuff leading us into the springtime. Those of you just joining us, we're just getting started. It'll take a few moments to populate. So I hope you got yourself a nice big cup of yummy breakfast drink. And Janda, why don't you go ahead and tell us what's coming up here on the webinars while people are joining us?
Well, then I'll have to repeat it because people may join us later. But next weekend, well, first, before we get into what's coming up, we want to let people know that they can view the ones that we have done in the past because they are recorded. And there are a couple places where you can view any of the webinars that we've done last year and this year since going into our work from home status and not being at the EnviroHouse. Next Saturday, we are doing spring gardens, starting your garden, knowing a little bit about soil and seeds and what kind of plants grow well in the Northwest. And Jenny, who has done many of our webinars, Jenny Call, will be leading us through that. She also does herbs and other kinds of chickens and fruit trees and so on. And then April is going to be Earth Month. The city is going to be promoting, instead of just Earth Day, we'll have the full month as Earth Month. And we'll be doing 2 and 3 activities every week. So we will have at least one webinar every week, if not 2, and then some panel discussions. The first week will be about food, starting with Jenny and the gardening. And then we'll be doing waste reduction. And a new topic, the third week, will be sustainable fashions, about fabric and fashions and saving money and things like that. I'm not leading that one. And then the last week will be sustainable communities. We'll be repeating our EV, electric vehicle one. So we're still kind of settling those in. We're hoping to do one on pollinating gardens and birds and some other new topics that we haven't done before. That's not all firm yet, but it will be up on the website and on the Facebook pages soon.
Excellent. And for those of you who are joining us today, as you filter in, remember that this is being recorded and we will have it available on the workshops page shortly. It takes a couple, maybe a week or so to get it up there. We're still working on some of those details on how to get things to you faster. I'm going to put in the chat. So if you open your chat, I'm going to put in the chat the email or the web address you need to go to check out those webinars and to register for those. That is cityoftacoma.org/workshops.
And then also the Sustainable Office Facebook page. Do you have a link for that?
I do not. So Facebook Tacoma Sustainability, though, I will.
Yeah, and if you just do cityoftacoma.org/sustainable or sustainability, it should get you to their website where you can find that. Other webinars and how-to videos are also on YouTube. The city has its own YouTube channel. So if you do youtube.com, I think it might be U.2. Tube.
Just YouTube, yeah.
.com / City of Tacoma /playlist. And that will bring up a whole slew of things.
And then you should be able to search EnviroHouse, and that'll get you. For those of you who are joining us, if you haven't done this before, we do have periodically the presenter will have questions in the form of a poll where you can answer, and it's anonymous. We also have question and answer. That's one way you can, the Q&A part there, you can ask questions in there, or the chat, and I'll be monitoring those things and I'll be asking them when it's appropriate. Let's go ahead and get this started. I'm going to show you what a poll looks like. So if you will, please vote in your poll. What do they say? Vote early, vote often. You can only vote once on this, but this gives you an opportunity for us to get to give us direct feedback. How did you hear about this webinar? Workplace email, EnviroHouse workshop webpage, EnviroNews email, friend, colleague, Facebook. Okay, if there's an other, go ahead and answer in the chat. If you also are in the chat, there's a little thing that says to all panelists. Switch that to all panelists and attendees, and that should get to everybody. Okay, I'm going to give you about 5 more seconds to go ahead and vote or answer your poll question. I need to poll. I learned about this from a friend or colleague. And then we're going to turn it over. Let's go ahead and look at those results. Here we go. So looks like our Facebook and Enviro News are doing a good job at keeping everybody learning about our stuff. So thank you for that answer. We're going to move on today. We are talking about heat pumps. So Janda, if you want to go and introduce our guests today. Thank you.
Okay, David Norman is going to do the beginning part, the presentation. David is an instructor with HVAC, and I'll let him explain all the terminology. And he has a school, so he trains people. He knows the system, the whole series really, really well. And David's done some work with us before, some presentations. And I believe you're still affiliated with CSI. Yeah. So I will let David give you the details of his background, and then Sarah Bowles will be joining us later on. Sarah will be talking about heat pump water heaters, I believe, and you're looking like that's a surprise, and the Tacoma power incentives. So I will let David introduce himself, and we will see you later in the production.
All right, so pretty soon here I'm going to share my screen, and we'll walk through a little presentation and some bullet points and talking points about our heat pumps. As Janda said, I've been hanging around the industry for quite a while. I started in 1978, and so pretty much doing this my entire career. I've been teaching for the college, 4-year apprenticeship program for 27 years now. I've been active in HVAC in all aspects, from design to service, install, and specialty type projects that I get called into for consulting work. And anytime you have questions about this, so Mondays and Tuesdays, I install and repair equipment. Wednesday through Saturdays, I teach my classes and help the competition for our company grow their technicians. My passion is really teaching and getting more women and minorities into our industry has been what I've been working with. I've been working with a group getting more military vets retrained for HVAC and being able to land them jobs. We just graduated 16 people and got all but one placed in new jobs now. So pretty exciting prospects. And so if you know any young women or men that want to get into the HVAC industry, make sure you have them contact me, and I'll see if I can help them land a job, how their employers pay for their education. It's pretty great deal. On with our prezo for today, with Tacoma Power, I've been involved with them for several years now. And let's bring up our presentation. So Sarah's going to be assisting me on this presentation. I'm hoping everybody's seeing my screen now.
It looks good on our side. Thank you, David.
Excellent, thank you. So heat pumps have been around for a long time, actually since 1948 was our first official heat pumps. Of course, air conditioning have been around since about 1902. So it's not a new technology of absorbing and releasing heat, and we're moving heat. So it's from space heating to heat pump water heaters, heat pump clothes dryers now. I haven't had the opportunity to work on one of those yet, but going to get my hands on one soon. How do they work? We're going to talk about that today. How come they're so efficient compared to electric strip heat and some of the other gas fossil fuels that we might have in our house? We're going to be looking at the reliability. Are there advantages or disadvantages to them? And with that, I wanted to be the instructor. I really like trying to learn something every day or try to teach something every day. And so I added a couple of slides to Tacoma Power's presentation here about heat in general. And heat is measured in BTUs. Temperature is how hot something is. A BTU is how much energy is in that substance. And so a British thermal unit is amount of heat to raise or lower 1 pound of water, 1 degree Fahrenheit is our definition of a BTU. And that's a 1 BTU is about a wooden matchstick burned down to the very end. And a ton of refrigeration is 12,000 BTUs. So if somebody comes to your house and says, oh, you need a 2-ton unit for your house, well, that'd be 24,000 BTUs, or a ton and a half might be 18,000 BTUs. So when they're talking about tons, they're talking about a ton of refrigeration effect. And I'll tell you how that came about. So 1 ton is 12,000 BTUs of being moved either from inside my house and moving that heat outside for my air conditioning, or I'll be absorbing it from the outside, moving inside my house. And beautiful thing about heat moving to cool. So the term ton comes from taking 32-degree ice and melting it into 32-degree water. So for every pound of ice, it took 144 matchsticks or BTUs to make that transition happen. And with that, so 2,000 pounds of ice or 1 ton of ice melted over a 24-hour period became our benchmark of refrigeration effect. And I don't want to get too technical here, but this is just a background of, why do we call it a ton of heating or air conditioning? And so I take 2,000 pounds of ice, takes 144 BTUs to change it from ice into water, and that's 288,000 BTUs. We divide that by 24 hours in a day, and we have our 12,000 BTUs per hour that your little air conditioner or heat pump is capable of moving. And that's a tremendous amount of energy. I know if I got a pile of snow sitting in my yard, it's going to stay there a while. Could you imagine a 1-ton block of ice, how long it would take to melt just sitting outside? And we're doing that every 24 hours period of operating time. So a tremendous amount of energy, and thermodynamics says, well, heat moves to cool. So if I can create a condition where my refrigerant coils are colder or warmer than the outside air temperature, I'm able to transfer heat. And so we're moving heat instead of generating heat like the fossil fuels would be doing. So they do not create heat, we absorb them. And that absorption can happen with a heat pump. People are like, oh, it's 40 degrees outside today. How can I heat my house to 70 when it's only 40 degrees outside? And we do that with making that outdoor coil about 20 degrees below outdoor air temperature. And because heat moves to cool, we're able to absorb heat from the outside air. That 40-degree air goes into my 20-degree coil, and then we pump that heat. And there's heat available all the way down to minus 460 degrees Fahrenheit. That's absolute zero. And so we're taking an advantage of this heat moving to cool. So heat is found in air, water, and ground. And that's how we classify a heat pump. Is it an air source heat pump, a water source, or a ground source? So that's where we're grabbing the heat from and moving it to the air inside of the house.
Hey, David, before we get too far along here, we do have an initial question we want to ask the group. Is that okay?
Sure.
All right, let's get that in there. And then I do have a question I want you to think about while I put this poll up there. Someone wants to know, why is the US still using BTUs? I mean, does Great Britain still use BTUs, or are they on the metric system? So I'm going to put up the poll question. How much of Tacoma's power electricity is generated by hydropower? 30%, 60%, over 90, or maybe you have another answer. Go ahead and answer that. What do you think, Dave? BTUs?
So on the BTU question, it is pretty much a standard. Of course, they're using Celsius instead of Fahrenheit conversions. And I do teach those in some of my college classes. But BTU has been an international standard. It's accepted worldwide, and it's a way for we can compare the European or the Asian market equipment with the American-made equipment, because they're all rated in BTUs.
Gotcha. Okay, I'm going to end the polling. It looks like everyone has their answer. I'm going to show this to you. I just wonder also, where do you get all those matchsticks to try to melt a ton of ice there?
Right, yeah.
So here's the results. Looks like everyone's guessing, most people are guessing or saying over 90%. I don't know. Yeah, 65 or 30. Maybe Sarah, you want to jump in and give us the answer on this one?
Sure. It's actually 97%, give or take. So we do produce a lot of our power. We produce about 40% of our power with our own dams, but we purchase the rest from BPA, who also has a very large portfolio of hydro. There is about 3% of coal power that we get from Bonneville Power Administration's portfolio.
Excellent, thanks. All right, David, you can get back to your presentation there. Thank you.
Excellent. So going with that, you've probably heard the terms evaporator or condenser. And so when my liquid refrigerant turns to a vapor, it evaporates and it absorbs heat. And so that's why we call it the evaporator. So in the air conditioning mode, our evaporator is the indoor coil. In the heating mode, that evaporator is the outdoor coil. And the opposite's true. When the vapor changes to liquid, it's going to condense and it's going to release its heat to the outside air if I'm in the air conditioning mode. In the heating mode, my condenser is on the inside of the house, where I'm releasing the heat out of the refrigerant that I've absorbed from outside. I've moved that inside with a pump. That's why we call it a heat pump. And we're releasing that heat into that from the refrigerant into the airstream. So as pressure rises, our temperature rises. So our compressor is taking a low pressure refrigerant and turning it into a high pressure refrigerant. And we move that inside the house, where we condense it back into a liquid so it can go outside and do it again. So just moving heat around in a circle. And as pressure drops, temperature drops. And so in our evaporator, we're going to drop our pressure, which drops our temperature. And sometimes, like we're running the heating mode, I'm going to have a 20-degree coil and I got 40-degree air. Well, 40-degree moist air is hitting this 20-degree coil. It's going to ice up on the outdoor unit. And so they have to go through what's called a defrost cycle to melt some of that ice off of it. And so it is a closed loop refrigeration system that has we're going to more, both the ozone depletion values have gone to 0 as we moved away from R22 to R410. And so we're using an environmentally friendly refrigerant. In the next few years, we'll be also lowering our global warming potential of the refrigerant by going to some what they call mildly flammable refrigerants. But don't worry, they're going to be enclosed in a closed loop system. They're not going to be able to get out and start a fire or anything like that. In fact, they might be able to propagate a fire, but they could not start one. So that's all good information for the technicians to stay up on what the new refrigerants are and how to safely handle them. We're going to take care of that for you. So heat pumps are giving us our heating and cooling. We have significant heating cost savings over electric heat and some of our fossil fuel heat. There's a chart later that helps explain some of these savings per therm, or a therm is 100,000 BTUs. So more efficient than other common HVAC systems, and definitely proven technology, especially when we're with our ductless systems. We don't have the heat loss of the ductwork itself being in our crawl space. And so a lot of these ductless programs are really saving a lot of energy, not only because it's a more efficient way to move heat, but it's also doesn't have the losses that are associated with the ducting system. Definitely a proven technology, been around for a long time. And it's beautiful that we live in the Northwest, because we don't get too cold in the winter. We don't get too hot in the summer in comparison to other areas of the nation. And because we're using hydroelectric power, we've got some of the cheapest power rates in the nation. So it's really a beautiful combination to have a heat pump in the Northwest. Low carbon energy solution, meaning we're not, because we're getting so much of our power from hydroelectric instead of fossil fuels and coal fire power plants, things like that. And we're using yet less BTUs or watts for our BTUs, I should say. We're able to have a very energy efficient system. So flexible design, we can have whole house systems, which would probably be ducted so we can get heat into every room, or we can have zone systems where we take care of the largest zone of the house, and then on the coldest days of the years we might bring on a little extra heat in the form of electric baseboard heat in the back bedroom, something like that. Or we can have a combination now where I can have a ducted system and a ductless system. And so maybe I want a ductless portion in the bonus room of the house, above the garage, or in the master suite upstairs, and then the rest of the house is on a ducted system. So it's very flexible, and whoever you have come out, take a look at a house, they're going to give you probably more than one solution, and you get to choose what's going to work best for you. There's our cost per million BTUs, so that's more than a therm. That'd be 10 therms. And so we've got our oil furnace and propane versus electric, and you can see that our ductless is our most efficient way to do this per million BTUs.
And David, that brings us to our next poll question here. And that question is, what kind of heat do you have where you live? And I did make this a multiple choice. So if you do have more than one thing, go ahead and pick the ones that you have. So we also have a fireplace here, but I guess it's a gas fireplace.
And I'm pretty sure I had seen this chart on one of the pages that's available at the Tacoma Power website. Is that correct? Or...
So I can't verify that is still up on our website. We used to have this information up there, but we go through changes so often, I can't guarantee that.
Okay.
Mm-hmm.
I'm going to go ahead and share. Looks like everybody answered. Just a quick question: do these rates change like dramatically, or are these pretty set? These costs. I mean, there's some change, but not massive changes.
Right. As our utility rates for both electric or gas, probably the ones that we would watch. There are times where the fuel costs go up in the winter and go down in the summer as far as oil goes, especially as the demand for oil goes up. Or right now, what's going on in the Suez Canal is greatly going to affect oil prices throughout the world. So that's not only gas at the gas pump, but also fuel oil for your house.
Fascinating. Thank you, sir. So we can look at the results. A lot of people have gas furnaces in our poll, electric and traditional heat pump. All right. Thank you, everybody. Go ahead, David.
All right. So like before, we were talking, I'm able to get what's called a coefficient of performance. When I'm looking at a heat pump versus electric baseboard heat, and when these programs first came out, we really concentrated on, getting rid of some of this electric baseboard heat and going to a heat pump, because it is 3 to 1 more efficient. So if it's 47 degrees outside, my heat pump is a third of the cost to operate than our electric furnaces. And then when it's 17 degrees outside, well, there's less heat available at 17 degrees outside. And we don't hit that type of weather very often around here. But if we do, the heat pump is still 2 to 1. So it is twice as efficient as the electric baseboard heat. And so that makes a big difference in your utility bill when we make that changeover. And that's why the people who have gone to these ductless heat pumps are pretty darn happy with them, because not only do they get a little bit of air conditioning on those really hot days of the year, but they get very affordable heat for their house. So I talked earlier about our options for gathering heat. And so air source is by far the most popular, probably the most cost effective for initial standpoint. Ground source is usually have to have about 1,000 feet of pipe in the ground for every ton. So if I needed 3-ton system for a house, I'd have to have about 3,000 feet of pipe in the ground in order to absorb that amount of BTUs out of the ground. And the ground temperature is 50 to 55 degrees year round. And so if we get that buried deep enough, we're going to be able to use an effective ground source. They have a very great payback rate, but it's a lot more dollars to begin with. Water source is tough to come by because some of the environmental rules are not going to let us change the temperature of a lake or a pond. And so they're pretty rare. There may be some that have been grandfathered in. Commercial buildings will have water source through a cooling tower and a boiler system, but for residential, mostly we're dealing with the air source products. There are central ducted system. This is our standard system. This can be both a single stage, a 2-stage compressor system, or it could be a fully modulating compressor to match the load of the house. And in this picture, I've got a heat pump. It looks like it's on top of a gas furnace and an AC heat pump coil on top of that furnace. And so that's what we call a hybrid system, where I have fuel, a gas furnace as my backup heat. So my heat pump heats the house down to 35 degrees. Below 35 degrees, I shut off my heat pump, I turn on my gas furnace. And once I get up about 40, 42 degrees, it switches back from my natural gas fuel back to the heat pump. And so once again, if you currently have a gas furnace, that may become your backup heat on the very coldest days of the year. So larger homes, existing ductwork, and very flexible with the existing ductwork systems. And they have many options for efficiencies and staging. The beauty of having a ducted system is filtration. And I'm pretty sure that indoor air quality and clean air is a pretty important topic in the last couple of years here. And people can go a little bit too far with that idea. They think, oh, well, if one filter is good, 3 must be fantastic, and it's not. It just chokes off the airflow and kills the system. So we've got to be careful of what filter we choose and what air cleaning products we choose. And your dealer is going to be able to help you choose what's going to be right for your house. Is it going to be a UV light? Is it going to be an ozone generating type of a machine that cleans the air that way, or clumps the particles together so that they fall out of the air? And what type of filter gets this down to the virus level so that we can capture that and get it out of the airstream? And some of the best ways to do that would be with a fully ducted system that your house might already have. And so we may be going to a system that has both ducted and maybe ductless in the same house. So obviously efficiency drops with the leaky ductwork. On this particular picture, the ductwork's inside the envelope of the house. So if it's leaking into the house, so not that big of a deal. But if my ductwork is in my crawl space or up in my attic, then I want to make sure it's insulated right, and I have to make it sure that it's leak free, that we've sealed all the joints so that I'm not sucking in this attic air that's got all this fiberglass floating around in it. And so I can have a cleaner environment in my home, I need to have tight, well-insulated ductwork. Our ductless heat pumps deal away with that. So I've got a wall unit. It does have a filter on it that we do have to keep clean, but it's pretty easy. I just pull it out, take it over the sink, wash it out, wring it out a little bit, throw it back up in that unit, and away we go. I have a condenser on the outside, and usually those condenser coils stay pretty clean with the exception of cottonwood. In the springtime, when the cottonwood starts floating down, it gets sucked right into the coil of that thing. And maybe once every 2 years, I have to take a light spray on a hose and squirt it in downward fashion and just wash that right off of there. It's pretty easy. Or you can pay a company to come do a regular maintenance for you. So best for smaller homes, additions, spot cooling. A lot of people are moving a home office. Maybe you've taken one bedroom and now it's a home office. And so now you need a little extra cooling just for that one room because you've got your computers and your monitors and, oh, well, I got my little mini fridge and my printer. And so I've got enough heat generated in that one room that if that one room wants cooling most of the year, and yet the rest of the house might want a little bit of heat. So having spot cooling with ductless heat pumps is a perfect way to do that. I've done a lot of those type of installs. And so I'm going to have a thermostat controlling the temperature for that specific area. That could be usually that's a wireless remote. And I know you're thinking, oh no, another remote. But we could mount that right on the wall for you. And then a combination mini split systems. We're able to have one outdoor unit with many different indoor units. It could be a ceiling hung, it could be hung in the attic, it could be the one on the bottom right is a, if I took away a baseboard heater, I could put one down low underneath some windows. A couple homes that used to have radiators, I take the radiator out, I put that one in the bottom right down on the wall where the radiator used to be, and I've got a great solution for that particular room. The wall units are probably the most popular and they're easy to maintain. I'm not going to have to climb up my attic and change a filter when I got a wall unit. So that's a pretty great way to go. So that's our flexibility depending on what your home might need. Another flexibility issue is sometimes I've got a 2-story house and upstairs I have 2 or 3 bedrooms and a bathroom upstairs. I can get this little attic hung unit, run delivered right into each room. and it's going to be able to supply the air that's needed for each little room up on the top floor. So that's a part of our whole house solutions. HSPF, a lot of people get so focused on SEER, and SEER is Seasonal Energy Efficiency Ratio, which we'll talk about in a minute. HSPF is our heating seasonal performance. This is a national average number that for heating, and I'm much more interested in my HSPF number than I am my SEER number, because there's 2,800 hours of heating a year. There's only 300 hours of cooling per year.
David, we do have a poll question, I think, that leads into this, and that is how efficient is a heat pump? Here you go, everybody. Please, this is just vote once. David, maybe you'll get to this. I'm curious about square footage of like one of the wall units. Maybe you'll talk about that in a little bit, like how much it would heat or cool.
Yeah, I'll give some generalizations or rules of thumb. I don't like rules of thumb because there's so many variables to this, meaning do they have single pane windows? Do they have double pane windows? What is the insulation in the walls? What's the insulation in the ceiling? All could change. So if I just say our 1-ton unit can handle 1,000 square feet or 800 square feet. Yeah, maybe they can, maybe can do more if they're
it's ideal, right?
Right, yeah.
Yeah,
and
sure.
It just depends on the age of the home, the construction type, and have we had any upgrades? And that's the beauty of Tacoma Power. We're able to get window packages done. We're able to get some insulation done through some of the programs that they have. So, definitely keep yourself informed about what's available to you.
Excellent, thank you. So here's the answers that people have put up. 63% said 100% efficiency. Others were on either side of that. No one voted, no one picked 250% efficiency. That's always been my rule of thumb, the highest number, but I didn't even pick that. So.
Yeah, what this poll didn't ask is in comparison to what? And in comparison to electric strip heat, it's 300% efficient when it's mild weather. And some of the mini splits are almost 400% in comparison to electric strip heat. And so that's all about the efficiency that you're willing to purchase. So our minimum federal standard is 8.2 on HSPF. And I think I like to see 9 or better being installed on my jobs, just so I know that they're getting the biggest bang for their buck. And if I've got that going for me, then I know that I'm going to have much greater than 14 SEER as being the federal minimum. We're going to far exceed that if I choose a good heating number. So like I said, SEER is 300 hours a year in Western Washington. HSPF is 2,800 hours of heating a year. So we want to really make sure our dealers know what they're talking about with the heating side of things. It's a different type of heat than we're used to. I got continuous heating at lower output temperatures. And some of our audience may have grown up with coal and oil furnaces where they had an oil conversion from a coil originally, and they're used to supply air temperatures that are 140 degrees or so. A heat pump's going to put out about 110 degree air or less as it gets colder outside. But instead of having big swings in temperature, I'm going to have a nice even temperature. It's like cruise control for your car. I got cruise control on a heat pump where I got a nice continuous temperature all the time. Slow to heat up because it has that lower initial temperature. In fact, most manufacturers don't want you to have a night setback at all. But if you do, not more than about 3 degrees on a ductless heat pump. So that's just saying, don't set it back more than a couple degrees. We got heat pump output varies with the outdoor temperature. You can get what's called hyperheat units, which will ramp up and give us the same amount of heat, even if it's colder outside. The cost for that equipment is a little bit more, but it's available. For the most part, most of these heat pumps, as it gets a little bit colder outside, my supply air temperature is going to drop with that, but it's not going to be a cold draft. In fact, that fan, when I turn it on the heat mode, my indoor fan doesn't even come on until my coil temperature is at least 10 degrees warmer than the space temperature. So it's not, and that's something that's a little different too. Maybe I'm used to my gas furnace coming on, boom, it's blowing a lot of heat right away. This thing warms up the coil and then the nice even heat all the time. So you're always comfortable.
David, I do have a question relating to the setback.
Yes.
How much does not setting back your thermostat at night decrease overall efficiency and savings?
They've kind of proved that anything higher than about 15 SEER, you don't see a decrease in savings by not setting it back, because bringing up the thermal mass of the house, if I cool off the house down to 60 degrees, heating up the air is easy, but now I got to heat up the walls, the furniture, the ceiling, the glass, and the thermal mass to bring it back up to 70 degrees takes more energy than it would have if they had not set it back. And that's just the cruise control version of keeping this modulating compressor. So as I need more heat, it ramps up, and I need less, it's going to ramp back down a little bit. And it always matches the output of the heat pump with the heat loss of the house. I talked earlier about defrost cycle. Did that answer your question?
I think so. I just wanted to clarify for me, is that the idea is to keep the temperature set to where you want it, and it'll fluctuate to get it back up and down there. You don't want to just turn it off and turn it on, turn it off, turn it off. Like, you want to.
Yeah, it is not made for turning on and off, on and off. It is not like our fuel burning appliances. It's a different type of heat, but it's a very comfortable, and I'm able to keep my humidity at a better controlled set point, because comfort is not just temperature. It's humidity, it's the air movement in the house, and it's sound levels, and I love how quiet these things are. So the one thing that people might not be used to is what's called a defrost cycle. And I rarely even notice when mine goes into defrost. And I'm pretty attuned to what heating systems are doing. But as it goes into defrost, it's going to switch basically into the cooling mode for a minute, melt the ice outside, but it's not going to blow that cold air into your room while it's doing that. So, but you might see steam coming up off your outdoor unit. Don't call the fire department saying, hey, my outdoor unit's on fire. That's just a little bit of steam rising as I melted that ice, and then it'll go back into the heating mode. Frequent filter cleaning is required. In the manufacturers of these things, oh, every month you need to do this. And that's great to keep them nice and clean. It kind of depends on who's living there. If I've got grandma and grandpa living by themselves and not that much door opening and closing, once every 6 months might be enough. If I've got kids and pets and dogs, I find once every 3 months is probably the schedule. And so, and in the summer, I need a little bit more than in the winter. If I got road construction going on there at the house, I'm gonna have to clean my filters a little more often. So I just tell people, check it after 30 days. If it needs it, great, take care of it. If it doesn't, just figure out what your schedule is gonna be for how you're living in your house. But kids and pets and that type of thing, I definitely see the added need to more frequently take care of these things. The equipment manufacturers just says, oh yeah, every 30 days. Well, they just want to cover the bases on whoever's there. But if I'm living by myself, and that's not, probably every 6 months is going to be plenty.
Now, this last year we had all those fires. That's probably a major concern then, like going through all that.
Yeah, and fire smoke is a unique particulate because standard filters do not absorb smell. And so if you need to absorb smell, you can get what's called carbon filters. And I was teaching people how to build their own carbon filtering system by buying a box fan and a 24-inch by 24-inch carbon filter, duct taping it to the back of the box fan, and that way they could absorb the smell out of it, because we'll get particulate matter out of the air with a standard filter, but we will not take care of odors unless we have carbon.
Thank you. That's a good tip.
So technology improvements, we've gone to what's called variable speed fan motors. As July 1st of 2 years ago, became standard that all indoor fans had to be of variable speed, or what we call constant torque motors that are almost 90% energy efficient compared to our old motors that had capacitors on them, and they were 60% efficient. So we've taken a huge jump in efficiency, and with inverter driven compressors, it's even more so. So we have quieter operations and happier neighbors. I remember when I started in the industry in the late 70s, I remember homeowners telling me they didn't want a heat pump in their house because it was so noisy. Oh, my neighbor's got one of those, and it's really noisy, and I don't want one of those. And today I can have a whisper, nice, quiet conversation sitting right next to one of these units. And sometimes I can't even tell that the unit is on unless I stand in front of it and feel the air blowing out of it. So these outdoor units are so much quieter than they were 40 years ago. And we have to be, because we have to be 45 decibels at night at the property line. And so that's what we call our setback. So we have to meet those sound requirements. So we already talked about mini splits, and now we have combinations where we have ducted and ductless together. And it has outdoor sensors for energy efficiency, meaning these mini splits have a lot of sensors on them. Some are on the refrigerant line, some of them are in the outside air, and that's when it's how it knows when to go into defrost. So it only goes into defrost when it needs to, not by time and temperature. It's doing it by demand. Does it need to or not? And which makes it defrost less than the old equipment, which makes it more energy efficient. We already talked about maintenance is critical, not only for the indoor unit. You can see how easy it is just to slide one of those filters out, wash it, and wring it out a little bit and put it back in. And so the manufacturer recommending that monthly changing, but my outdoor unit definitely needs room to breathe. I always tell my students, if your system can't breathe, it will die. And you don't want that kind of investment. There's a cost to ownership of your car. You're going to take care of it. There's a cost to ownership of your heating system, meaning take care of it. Don't let the rose bushes take over and the ivy take over this outdoor unit. We got to keep it clean and clear. And you can see the fan at the front of that on the left-hand side there. It's blowing air out, and I don't want to obstruct that. People want to put, I need a beauty fence around this thing so people don't see it from the street. Well, that's got to be at least 2 to 3 feet away so that I have enough airflow coming off that. I can be as close as 8 inches away from the wall, depending on the brand. So I'll be pretty close to the wall of the house, but I need air to go through that thing so I can breathe well and absorb heat like it needs to. There's lots of brands. Everybody makes a pretty good box. Some of your dealers may offer a 2-year warranty. Some of them might offer a 5 or a 7-year warranty. Just depends on how many they sell a year. But every brand makes a pretty decent box. Every brand, it behooves the manufacturer to stand behind that product because they don't want to end up on the news saying that they didn't take care of their people. So I'm really, that's the warranty and the term of coverage. Talk to your dealer that comes to visit you and get that information from them. What size is right? So that kind of leads us to, you know, oh, I can put a 1-ton unit in and it does X amount of square feet. Well, we really got to look at the home and figure that out. And this chart is called a balance point chart, where we have a heating loss. Anytime I'm below 70 degrees in the house, I'm going to have some sort of heat loss in BTUs. And so I'm going to take care of that with my heat pump. At some point, usually around 32 to 35 degrees, your heat pump may need some help. Now I can get these whole house solutions that take care of it all the way down to, you know, our winter design temperature. And typically our winter design temperatures usually around 22, 26 degrees, depending on what neighborhood you're in. And we really don't spend that much time below that temperature where we would really need backup or supplemental heat with that.
You're going to answer about insulation. I was just going to get to a question that does the sun affect the outdoor unit efficiency, and does putting it on a shadier side of the house help? If you could talk about placement when you get a chance. So I see you're leading into that.
I love that. I think there is something talking about placement a little bit. This is a statement that we talk about in my college classes, and having it on the south side of the house or the north side of the house really doesn't affect it all that much. I mean, can I get a little extra solar gain in the winter by having it on a sunnier side of the house? Yeah, there's a little bit of gain there. And since I'm doing more heating than cooling, I can see wanting to have it in the sunshine, but it is absolutely not necessary. These things are made to work in New Mexico, Arizona, and 110 degree outdoor air temperatures. They're made to work down to -5 degrees with our extended heat range models. So it just doesn't make that much difference on my bill. You know, I might pay a couple of dollars less in the winter if I put it on a sunny side than I did the shady side, but it's really pretty negligible as far as the cost to operate.
Thank you.
Yeah. A location of our indoor unit. The utility program here for Tacoma Power, if we're just adding one to a house, they want it in the biggest room of the house. We want to make the biggest bang for the dollar that Tacoma Power's picking up for you guys and for you. If you're stepping up and getting a better system, you may be paying some differences there. And depending on it's a part of the rebate program or not, and I'll let Sarah talk about that here in a few more slides. But if I'm in the biggest room of the house and I'm blowing this air down to the rest of the house, down the hallway, maybe I'm taking care of the living room, the dining room, and the kitchen, all with one location. We're trying to find the best air path to spread out and take care of the most heat loss in the house. And usually that's going to be our largest rooms of the house. Back to that location of the outdoor unit. where they say setbacks, that's how far from the property line. There's codes for the fire department. They have to have a certain number of feet next to the house to be able to get around your home in case of an emergency. So we got to pay attention to those things. If it's very narrow space, and if I can touch your house and touch the property line, it's probably not going on that side of the house. And so for me to pull a permit, I have to talk to the building department, tell them where I'm going to put this thing, and they're going to give me an approval or not. And I try to keep them away from being underneath a bedroom window, even though these models are so quiet, it probably doesn't matter. So I definitely want best airflow for the equipment. And then they have very low amp draw characteristics. So the electricians is going to be able to pull a circuit over there, power up the outdoor unit. As you can see, we have an electrical disconnect next to these outdoor units, whether it's hung on the wall or if it's down on the ground. And there could be advantages for either way. Sometimes I've had a guy's going to say, oh, you can put it right on the deck. And then it's like, no, I'm replacing my deck next year. So I put it up on a wall bracket and he can change his deck out and I don't have to move my unit. Having it on the pad on the ground is great because there's less energy transmission from the unit to the house. So that might be a quieter install by having it on the ground. Dogs think they are a fire hydrant. I love that picture. I have seen that many times. And the beauty of the mini splits is it's a lot tougher for them to use this outdoor unit as their personal place to go. I'm not saying they won't try, but it's less likely that they'll damage the coil. But I have had a few people that had to put a little fence around the unit to keep the dog from chewing on the lines and things if they had a puppy. So that could be a consideration with pets. There's other heat pump appliances out there. I know that the heat pump water heater market has just jumped by leaps and bounds. And I maybe Sarah could talk a little bit more to the our dryer capabilities. And you ready to take over now?
I would love to. Yes, thank you, Dave. So yes, there are two other technologies that are somewhat new to our market. And we're going to start with the heat pump water heater because a lot of people know about that, and also it's one of my favorites. So the heat pump water heater is amazing. One of the two things that your house uses when you're heating with electricity is space heating and water heating. Okay, and traditionally we've used electric resistance to do that, and that takes up a lot of energy versus the heat pump technology. So heat pump water heaters can save you a ton of money, just like heating your space in your home. It uses the same technology as the central or the ductless heat pump. And the units they sell now, you can have an all heat pump water heater, or you can have a hybrid. And hybrids, I think, are the best ones. So let's talk about a few positives and negatives about heat pump water heaters. They can be a little slower to heat up, okay? Let's say you have a big family, 5 people, we're taking lots of showers in the morning. That can really deplete your tank of hot water. And so it's going to take a little bit of time to get that back up to heat so you guys can, turn around and do that all over again. Now, when you have that hybrid mode, let's say that you do have a huge family and you have all the extended family over for a visit, and your tank needs to really keep up with this higher demand than normal. You can switch it back over into resistance heat to get that water heated up immediately to provide more showers for that extended family. So that is a great thing to look at when you're looking for a new water heater, and specifically a heat pump one. A couple of other things is location. There needs to be some airflow, because just like the outdoor units, the ductless and the central, it is going to absorb the heat from that space, put it into the tank, heat that water, and then there's also going to be an exhaust of cold air, just like the units outside. So you need to think about the location. You can't really put it in your closet because it's going to absorb the heat that your hopefully existing central or ductless heat pump is putting into the home, and put it in there and then blow cold air out. So if you are putting it in a conditioned area, you might have to have a couple extra steps of ducting this thing in and out, okay? One of the best locations is in the garage, okay? Because hopefully nobody's heating their garages. I know I don't. That way they can absorb the heat from inside of that garage, which is going to be very similar to that outside temperature. And then as it expels that cold air, it's just going to go into your garage and not affect your comfortability inside of your home. So those are some pros and cons about that. We do have a rebate for it, and I will probably talk about that in the next slide. So let's talk about the heat pump dryers. Those sort of the same thing. They're awesome. They do traditional dryers because they use resistance heat. It does use a lot of energy. So when you switch over to that heat pump technology, you're going to save a lot of money drying your clothes. Now, what I've heard, and I can't be attesting to this because I don't have one. The only thing I have is a ductless heat pump. But they say that it does take a little bit longer to dry your clothes. I don't know. I can't swear by this, but that is the word on the street. So if you, again, let's go back to that big 5-person family with several little kids. And if anybody's had any children, you know, you do laundry at least 3 times a day because kids are messy. Let's just be realistic about that. So if you do have like a high demand on your washer and dryer, a heat pump dryer might not be the best solution for your home. But if it's just you two, retired, taking it easy, maybe doing laundry once a week, got time to wait that extra time to get those clothes dried, then you know maybe the heat pump dryer is going to be a good application for your lifestyle. So those are some pros and cons on the heat pump dryer and the heat pump water heater. Dave, did you have anything to add to that? You're on mute still.
Oh, I would think that a lot of homes have the dryer out in the garage, so same thing. That would be a good location for it, because if it's in the house, obviously it's going to be blowing cold air into that room a little bit. But that's the only other thought I had on it.
And the other thing I forgot as well is that traditional dryers need to be ducted outdoors, right? That is not the case with the heat pump dryers. You don't need to have that exhaust to the outside of your house with this technology.
Right.
Awesome. Well, I think next up I get to talk about, I think we have a poll question.
We do. You wanted to get to know the question. This one is, have you participated in the Tacoma Power Rebate or Loan Program? Yes, no, or not sure. Ooh, looks like you're going to have some new customers here. Let's see. Most of everybody has voted or answered, and it looks like I'm going to end the polling. 80% said no.
Oh, all right. Well, this is a terrific segue. So let's talk, and Dave, if you want to switch over to the next slide, let's talk about our Tacoma Power heat pump programs. So we have 3 different offerings when it comes to heat pumps. We have a lot more, and after I talk about the heat pumps, I'll give you kind of an insight to the rest of the programs that we offer. So we do offer ductless heat pumps, central heat pumps, and heat pump water heaters. We have both a rebate and or a loan for all 3 of those options. And as you can see here in the slide, there's the breakdown of the $500 rebate for the ductless and the heat pump water heater, and then a $1,000 rebate for the central heat pump. I would like to mention, because I did note that 58% of our guests today are heating with a gas furnace. Well, good news. when it comes to qualifying a home for a ductless heat pump, a central heat pump, we don't look at the existing heating type anymore. Those rebates are available to any customer that is a Tacoma Power customer. Okay. So that means you can keep your gas forced air furnace and add that central heat pump and get $1,000 rebate. Now, the drawback is that if you are adding a central heat pump, we can't offer the $10,000 loan to you, and I apologize. But if you do have a gas forced air furnace and you want to add a ductless heat pump, we do have a $4,000 loan available to you. But Dave talked about some of the pros and cons between central and ductless and how it would apply to your home.
I do have a couple questions on the board here relating to the heat pump dryer and the heat pump water heater. Can you install a heat pump water heater outside in a covered area? I'll let you guys answer that.
I'm gonna have to look at the specifications on that as far as what outdoor temperature they're still pretty efficient at. And so the manufacturer of that, both the heat pump water heater and or the dryer might have a limitation on that. I have seen them outside, but I don't think once I get to a certain outdoor temperature that it's gonna work efficiently. And so we need to refer to the manufacturer's guidelines on that question. And I mean, I'll do some more research on it, but I believe we're going to try to keep it in a garage application where we're not subject to extreme colds, especially when they're attached garages.
Excellent. And then does a non-ducted heat pump dryer send all the moisture into the home?
I don't know the answer to that. I have not installed one yet. And so we'll, and maybe Sarah knows a little bit more about that part of it. And so we need to find out. Because
So,
I haven't done one yet.
yeah, let me take a shot in the dark on this one. When I was talking to my boss, he did mention this one. Oh yeah, don't forget to mention. Understanding kind of like the science and technology, I suppose. So this is my educated guess, is that when we're drying with the resistance heat, you're heating up the water, which is making this
Paper.
vapor, exactly. And with the heat pump dryer, it doesn't use that high hot heat. So maybe that vapor is not as noticeable, or maybe there is some sort of internal filtration system that maybe recaptures it and puts it back into there. Again, the dryers, I'm not very proficient in those. It is a new technology, and I'm sure once it becomes mainstream in our market, that's going to be something that Tacoma Power will offer rebates on. But at this time, this is not a mainstream product. There's definitely, what do they call them? The early adopters. We're still in the early adoption phase of heat pump dryers.
Excellent, thank you. We have a question about square footage. We kind of answered this, but regarding the ductless heat pump, you mentioned it's good for smaller home. Is a Rambler with 1,550 square feet qualified for the system? I think you mentioned that, you know, there's so many factors on how much it can actually work. If the insulation's perfect, if the, you know, the windows are double pane and all those. So I guess it's, yeah.
I'll jump in on that one real quick, and then Dave, I'm going to let you kind of follow up on that. As Dave had mentioned, it really depends. But to give you an example, and in fact, Dave did install my ductless heat pump. I have a split level, about 3,000 square foot home, and I have a 2-ton unit, and it is what I supply my house with year round. I don't use my baseboards in any of my bedrooms. I have both of the indoor units located in my main living rooms, both upstairs and downstairs, that blows down my hallway to heat all of my bedrooms. So that works for my house and my configuration of my bedrooms and my living rooms. And I guess the quick answer is I think yes, ductless heat pump would be a good application for a 1,500 square foot Rambler. I guess it would also depend on your needs. A lot of people want to have cooling in their bedroom and they want it really cold at night when they sleep, especially summertime. So that might be something to think about, is have one in your main living area to offset the majority of your heating and cooling needs of that home, but then have an additional unit, a smaller one in your bedroom to really give you that direct heating or cooling for that other space that you live in, your bedroom, when you're not in your living room. Dave, did you have anything to add to that?
Yes, I really like the idea of zoning by equipment. So if I got different zones of my house, I can have a small piece of equipment in that back bedroom. I can have a large piece of equipment handling the main area of the house. But another option now, as we saw with that, it's a lot more flexible. I could have one outdoor unit hooked to many indoors, and that could be a small ducted in the attic, handling several rooms. Oh, and so we're able to have maybe a 2-ton unit, and it's only doing a 1/2 ton in the back bedrooms, where it's doing a 1.5 tons in the front. So there's so much flexibility. Just get your dealer out there to look at the configuration of your house and have them give you a couple of solutions so you can pick the one that you like best.
Excellent, thank you. Yeah, it really just takes that individualized examination of your house, right? So
Yeah,
right.
Absolutely.
It
Go ahead,
really
Sarah.
does. Okay, so I hear that there's a question that we want to hear more about our central heat pump offerings, rebates, and such. And thank you very much for that question, because even one of the people, a program coordinator, I know these programs in and out. They are hard to understand. So I will do my best to fully describe it and articulate this. So we do have a central heat pump program, and any house with any sort of existing type of heat can qualify for a central heat pump rebate of $1,000. If you do have, let's say, a broken heat pump and your backup is either gas or electric, you do still qualify to get that upgraded or replaced under our program. That is one of our newest offerings that we have. Before, we were replacing old central heat pumps, but we have found that there is energy savings in there, because of course, if you're not heating with the central heat pump and you're just using your electric forced air furnace, you're going to be using a lot more electricity. So let's just replace it and not make you spend that extra money. The loan option, and please, if you have any questions, put them in the chat and I'll answer them as I go along. So the loan option of $10,000 is awesome. We have a 7-year 0 interest loan. Again, this is for existing electric forced air homes to get that central heat pump installed. And I see a lot of heat pump projects come through. They hit somewhere close to that $1,000 mark. I've seen them as low as like $7,000 for a new air handler and central heat pump, but that was like homey hookup from the cousin that owns his own HVAC company, giving you an excellent price. But for the most part, $10,000 is going to cover the most of your install. Now, if you want to start, and this is something that has been very popular this last year, is adding air scrubbers. And I don't understand the technology of air scrubbers. Dave can probably speak to that. But air scrubbers has been really popular when we've been dealing with this pandemic and, of course, these air particles. That can add some more money onto your unit. But if you are somebody who has respiratory issues, money's not really an option when it's talking about your health and keeping you safe. Let's see here. I think I saw a question. What HVAC companies are part of the loan program? Thank you for asking that question. 7 years for the loan, 7 years, 0 interest. So we do have a Trade Ally network, and you can find that on our website. And only the Trade Allies that have signed an agreement with us are able to offer that 7 years, 0 interest loan for either the ductless, the central, and our newest loan for the heat pump water heater. Okay. You can easily find that when you go to our website, and I don't have the link right off the top of my head.
I'll get that there. Don't worry.
Beautiful. Yes, when you go onto our website and you're looking at, Tacoma Power rebates, it says find a contractor. You click on that button and it's going to take you to a place where you can search out residential specific. I'm looking for HVAC, central, ductless, whatever it is you're seeking out. It looks like our is in the chat box now. And then you can go ahead and look through all of our contractors. They're all really great. They're all vetted. Myself plus 2 other auditors are continually doing inspections on all of their work to make sure that they are providing a high quality product and service to all of our customers. And I also want to mention that even though we've had to social distance for the last year or so, we have continued to keep this quality assurance on all of our contractors through video inspections. So just because we're all working from home doesn't mean they get to get away with any sort of sloppy installs, which they would never do anyhow, right, Dave?
That's correct. Yeah.
All right,
Yeah.
so we got a question in here. With the removal of existing system requirements removed, can I apply retroactively? Unfortunately, Alex, no. The program rules for all of our different measures is we will pay a rebate. Sorry, Alex. We will pay a rebate up to 90 days after install. So if it was 90 days ago, heck yes, get your stuff submitted, but it would have had to be with an existing contractor on our list. So that's unfortunate. We got another question.
Okay, we have one. Are these heat or water heat pumps operated with either gas or electric? Any solar powered heat or water pumps?
Okay, so these heat or water pumps. So the heat pump water heater, let's talk about that. If it's okay, we'll switch gears over to heat pump water heaters and our offerings. So to qualify for a heat pump water heater loan or rebate, you do need to have an electric water heater existing. Of course, the name of the game of our program is saving energy. So if you have a gas powered water heater, then that's not going to qualify for it underneath our program. But by all means, you can definitely get that installed if you feel passionate about it. And so what rebates or loan options are there for folks with gas furnace and gas water heaters currently? So I'm going to repeat, we don't have anything for gas water heaters, but for gas backup heats, you can add a central heat pump for $1,000. You could add a ductless heat pump, either whole home system, single, one-to-one unit for a $500 rebate or a $4,000 loan. All of our loans are 7-year, 0 interest, with the exception of if you are getting a heat pump water heater. We have the $2,200 3-year loan if you're just getting the heat pump water heater. If you combine that with other measures that we're offering, that loan will go to 7 years.
Excellent. I think we're going to wrap up the questions for now. Can you guys give some information where people can either email or contact, who they can contact for further questions specific, because some of these are getting kind of specific. And we're extending our time. So let's finish up our presentation and move forward. So.
All right. Thank you so much for that time check. Okay. So real quick, if anybody has any questions, feel free to call in to our office. We do, even though we are not back in our physical office right now, 253, and in fact, if we can get this in the chat, 253-502-8363. That is our main number. This is where you're going to get a hold of any one of our very knowledgeable staff to be able to ask them some questions. And if those questions get super technical, they will refer you to one of our subject matter experts, okay? And that means if you want to call in and talk about solar, if we want to talk about electric vehicle charging, if we want to talk about insulation, windows, any sort of weatherization and HVAC, call in, you will get to the right person. I also highly suggest you start at our website. We have a lot of information there. And from there, if your questions are not answered, pick up that phone and give us a call and we'll get that taken care of. And thank you. It looks like we have our link put into the chat again.
Yeah, I got that, the customer service link. So
Thank you so much.
Thank you.
I hope, well, and I don't know if that's a customer service link to us or to the main customer service for like bill pay and stuff like that. But either way, if you call them, we work together. We're a good team. They will get you sent over to us if you get to the wrong person.
Excellent. All right. David, do you want to wrap up anything on your end?
No,
finish
I
it.
think she covered it very well
Excellent.
there.
Well, let's bring Janda back in. I want to thank you both for joining us and everybody who's in the attendance today. Don't forget, this has been recorded. You can look at this at any time. Once we get it uploaded to the website, it'll be available at cityoftacoma.org/workshops. Don't forget, coming up, more workshops coming up. But David and Sarah, thank you so much for joining us and all that helpful information.
Welcome.
Okay. And I want to thank David and Sarah too. I haven't seen them for a year or more, working with from home for all of us. So I really appreciate having you both here and getting to see your faces again. Gator, I thank you too, but I see your face a lot. So I did want to mention also to check the City of Tacoma YouTube channel. There's a lot of information on that site, a lot of our recorded videos and the how-to videos, as well as the EnviroHouse website. And coming up next Saturday, we are doing gardening, getting your summer garden started with soil and planting tips and seeds and a lot of information from Jenny. On the 8th, we will be doing one that will have some good information about healthy soil, but it will also have a lot of information on how you deal with soil and food waste and how that affects climate change. So that will be a late afternoon. That'll be 4:30 to 6, I believe, on the 8th. We are hoping to get one on either and or pollinator gardens and how to attract birds to your yard that Tacoma Audubon will be doing. And then on the 17th, the city's sustainability office is promoting a litter-free 253 that will be an all-day pickup opportunity, pickup litter, and working in neighborhood groups on that. The 21st, we'll be doing one on sustainable fashion and fabrics. And on the 24th, there is a thread cycle. So the city is sponsoring an event at the Recycle Center where you can take fabric and thread and all kinds of related things and go turn it in if you don't want it anymore, so it can be recycled and reused by somebody else. And the last week, we'll be doing electric vehicles on the 28th. There will be one on cycling that I believe is on the 30th on bicycles and repairing flat tires. And the woman that's teaching this from Second Cycle, she said she hasn't had a car for 20 years. She just rides her bike everywhere. So way to learn some cool things from that. And then that last Saturday, we will be doing an intro with the tool library, which has moved. The Tacoma Tool Library has moved to the Tacoma Public Library downtown. And that will be an intro on how to find them now, what you can do with them, what kind of tools you can use, and some really good information there. So we may even be adding a couple more things yet, but that will be our Earth Month activities. So,
and I did put a link to the Earth Month page, which has a calendar there, so you can see what's going on through the Earth Month as well.
Then I did send you that. I don't know if you can pull that up as a screen share, that document I sent you.
Oh, yes. Let's see if I can.
If you go online and look up cityoftacoma.org/sustainability, it will take you to the Office of Sustainability website, and that has it shows the links for their Facebook page and their web page and ways that you can pull up other information about this event.
Sadly, it's not very large. Let me see if I can make it bigger. Yeah, not much.
Well, that gives them an idea what it looks like.
Yeah. So definitely
So-
check out the city of Tacoma. A lot of resources there as well.
So thank you all for attending and hope to see you again at a future event.
Don't forget to register. If you have any questions, please feel free to email us. Thank you, everybody. Goodbye.
And go join up and take HVAC classes.
There you go,
That's it.
right?
Yeah.